Good day everyone, welcome to our YouTube channel. For today's video, we have two objectives. First is to identify other trigonometric ratios using trigonometric identities. And second is to solve word problems using trigonometric identities. First, let us try to identify other trigonometric ratios using trigonometric identities. For our first problem, we have sine theta is equal to negative 3 over 5. And our given theta is at quadrant 4. We have to find cos theta, tangent theta, cosecant theta, secant theta, and cotangent theta. So basically all the trigonometric ratios. Moving on to our solution, let us first derive our formula. We have sine squared theta is equal or plus rather cos squared theta is equal to 1. We have plus over here. Now, let us substitute our value, which is sine theta is equal to negative 3 over 5 squared plus cos squared theta is equal to 1. Let us rewrite negative 3 over 5 squared. Now we will transpose cos squared theta to the other side. But first, let's square the sine, which is negative 3 over 5 squared is 9 over 15. And rewrite cos squared theta is equal to 1. Next is, let's transpose 9 over 25 to the other side. Positive, so we will have negative. It's supposed to be negative, sorry. Let's rewrite the value of 1 to the other value of 1, which is 25 over 25. Plus 9. That's negative. That's minus. Cos squared theta is equal to 25 or 16 rather. That's minus over the top. 16 over 25. Extracting the square root of cos squared theta, we will have cos theta is equal to 16 over 25. Square root of 16 over 25 is 4 over 5. So therefore, our cos theta is 4 over 5. By having this, we can find the tangent theta, because tangent theta is equal to sine over cosine theta. Tangent theta is equal to our sine, which is negative 3 over 5 over the value of cosine, which is 4 over 5. We can cancel out both the denominator because they are both 5. We will have negative 3 over 5. Or 4 rather. Next, we can now find their reciprocated value because we have the value of sine, cosine, and tangent. We can now find cosecant, secant, and tangent. So let us first write the values. The reciprocated value of sine is cosecant, and the value of cosecant is 5 over 3, negative 5 over 3. The value of secant, which is the reciprocated value of cosine, is 5 over 4, and cotangent is 4 over 3. Moving on to our next problem, we have our given tangent theta is equal to 2. We have tangent theta is equal to 2, and our given theta is at quadrant 3. We have to find the other trigonometric ratios. Trigonometric values or ratios. So our given is the tangent. By having this given, we can find the sine and cosine using the formula. C is equal to C is equal to the square root of x squared plus y squared. Substituting the value, we have our tangent is y over x, and our value of tangent is 2 over 1. That's x and y. X over y. Y over x rather. Y over x. Yeah. Now, substituting the value, we will have the square root of 1 squared plus 2 squared. 1 squared is 1 and 2 squared is 4. Now, add it, we will have square root of 5. So, therefore, our value of c is the square root of 5. By having the value of c, we can now find the sine and cosine. Sine is y over c and cosine is x over c. Yeah. Now, our value of y is 2. From the tangent, our value of y is 2 over the value of c, which is square root of 5. We have a radical denominator, so we have to rationalize it by multiplying it by square root of 5 over square root of 5. We will have 2 square root of 5 over square root of 5 multiplied by square root of 5 is 5. So therefore, that is our value of sine. Moving on to the value of cosine, our x is 1 over c is square root of 5. Again, rationalizing it, multiplying it by square root of 5 over square root of 5, we'll have square root of 5 over 5. So therefore, that is our value of cosine. Now that we have all the 3 basic trigonometric ratios, we can now have their reciprocated value. Let us first write their value. Tangent theta is equal to 2. Sine theta is equal to 2 square root of 5 over 5. And cosine theta is equal to square root of 5 over 5. Now, cosecant is the reciprocated value of sine theta. So, let us first write this. So, the cosecant theta is 5 over 2 square root of 5 from sine. The second theta, we will first rationalize this. Rationalizing it, we will have 5 square root of 5 over 10. Moving on to second, we have 5 square root of 5. Rationalizing it, we will have 5 square root of 5 over 5. Cancel out the 5, we will just have the square root of 5. Then moving on to the tangent or cotangent theta, the reciprocated value of 2 over 1 is 1 over 2. So therefore, the cotangent is 1 over 2. So from the value of tangent theta, which is 2, we have our sine, which is 2 square root of 5 over 5, cosine, which is square root of 5 over 5, cosecant, which is 5 square root of 5 over 10, secant, which is 5 square root of 5 rather, and cotangent, which is 1 half. Now that we're done to our first objective, let us now proceed to our second objective, which is solving word problems using trigonometric identities.
So, this is our first problem. A surveyor measures the angle of elevation theta from a horizontal point to the top of a tower and finds sin theta is equal to negative 3 over 5. Using trig identities, find cos theta. So, first, we will do our sketch. Our sketch here, it means on top of a tower. So, it will be from a tower and then to the bottom. So, we will have a right angle kind of representation where angle of elevation is equals to negative 3 over 5, which is our sine. Now, this is our sketch and this is our given as well. Negative 3 over 5 or sine is equals to negative 3 over 5. And our unknown is cos theta. So, we will find that. So, to do that, we will use this formula. So, our formula is sine squared theta plus cos squared theta equals to 1. That will be our formula. So, first, we will substitute the sine in our formula. So, negative 3 over 5 squared plus cos squared theta equals to 1. We will square that. So, it will equal to 9 over 25 plus cos squared theta equals to 1. Now, we will transpose 9 over 25. Now, once we transpose that, it will become negative 9 over 25. Now, so, it's now a fraction and whole number. So, to minus this, we will go with 25 over 25 minus 9 over 25. So, 25 minus 9 equals to 16 over 25. We will copy the denominator only. And now we will square them both to remove the squared. And so we will have cos theta is equals to 4 over 5. So now that we have our cosine theta, we will now write our conclusion. So, our conclusion would be, therefore, the cosine theta of sine theta equals to negative 3 over 5 is 4 over 5. So, this is our second word problem. An engineer designing a ramp knows the ramp angle theta satisfies tan theta equals to negative 3 over 4. She needs sine theta for calculation. Find sin theta using a trigonometric identity that uses tan theta. So, we have our given and unknown. So, our given is tan theta equals to negative 3 over 4. So, that is our given. And so, based on the problem, our unknown is sine theta. So, we will have to find that based on the problem. Now, we will solve it by using this formula. So, our formula is c equals to square root of x squared plus y squared. And now, we will substitute our given in our formula. So, our 3 is our y, while the 4 is our x. So, negative 4 squared plus negative 3 squared. So, if we square this, it will be 16 plus 9. Now, we plus both of those, it will become 25. So, the square root of 25 is 5. So, therefore, our c is 5. So, in our tan, we have negative 3 over 4. We know that negative 3 is the numerator of sine. We only have to find the denominator, Well, since we solved for c, our denominator is 5, so therefore our sign is negative 3 over 5. Negative 3 from the tan given and the 5 from the c, so therefore our sine theta is negative 3 over 5.
Now that we are all done, I hope you learn all about trigonometric identities and its use about finding other trigonometric identities and its real-life application. That's it for this video and stay tuned for more.